Hello, my name is Logan Mikaere and this is a Tokomaru Bay Wharf restoration project. Just some background about the Tokomaru Bay Wharf. The Tokomaru Bay Wharf was constructed during the early 1900s with the completion of the concrete wharf being in 1940. Since then, the Tokomaru Bay Wharf reinforced concrete sections have heavily deteriorated, which meant that access to the wharf can no longer be granted to the public due to safety concerns. The Tokomaru Bay community are currently in works to restore the historic wharf using conventional methods, but are having problems with additional cost and labour. Therefore, an alternative method of restoration is required. Why avoid conventional repair? Pile repair presents difficulties with concrete formwork. The underside of the decking is deteriorated, which means that you have to do overhead repair, which is really difficult. The marine environment presents uncontrollable issues such as high tides, wind conditions, things like that. It's also time consuming and expensive. The method that I have used is to analyze the existing wharf structural details, research existing conventional footbridges, investigate material properties, analyze structural forms versus span and additional load versus span, utilize the existing wharf as the foundation for a new decking system which will minimize pile repair and decking repair. Here you can see the structural details of the Tokomaru Bay Wharf. The Tokomaru Bay Wharf is 3.6 meters in width, and the span between piles can range from 15 foot, 17 foot, and 20 foot. This research will focus on the 20 foot span, as approximately 75% of the pile sets span 20 foot. Footbridge structural forms that were considered for this project were truss bridge, cable stayed bridge, beam bridge, and a suspension bridge. Materials that were considered for the footbridge design are structural steel, timber, concrete, titanium, polymers, and other materials. Here you can see the structural form versus the span for the conventional footbridges that I have come up with. The steel truss concrete decking has a maximum span of 60 foot. The steel truss wooden decking has a maximum span of 80 foot, along with the pure titanium truss wooden decking and pure titanium truss concrete decking. The steel mast cable stayed bridge has a maximum span of 240 foot, whereas the titanium mast cable stayed bridge has a maximum span of 200 foot. Do keep in mind that these maximum spans are relative to how these conventional footbridges were designed, but all the truss bridges were designed in the exact same way, and this can be said for the cable stayed bridges as well. Here you can see the additional loads that the conventional footbridge designs that I've come up with will have on the piles. Now, if you look to the left here, the yellow and orange lines represent a steel truss with a wooden decking and a pure titanium truss with a wooden decking. The grey and blue lines here represent the steel truss with a concrete decking and the pure titanium truss with a concrete decking. These larger loads and larger spans come from the pure titanium mast cable stayed bridge and the steel mast cable stayed bridge. The conventional footbridge designs will be incorporated by utilizing the existing wharf as the foundation for the new footbridge, which would allow minimal repair to the concrete piles and concrete decking. This is because the conventional footbridge designs are able to span over a set of piles, so these piles no longer need repairing. If you look to the figures on the right, the piles highlighted in pink represent the repaired concrete piles, and the piles that aren't highlighted in pink represent the unrepaired concrete piles. Here you can clearly see that the truss bridge here spans from this pile to this pile, which means that these piles will no longer need repairing. In conclusion, utilizing the different structural forms, the additional loads that the structural forms present on the existing wharf, and thorough research on the expense these conventional footbridge designs would likely cost, conclusions can be drawn on the most appropriate choice that would benefit and suit the Tokomaru Bay's community's needs, which are to find a solution that is both cost effective and presents the least amount of issues. I hope you guys enjoyed my presentation and learnt a thing or two about how conventional footbridge designs can be used to repair the Tokomaru Bay concrete wharf.